While this misting fan offers momentary relief, the heat it combats is an active, daily threat to survival. When ambient temperatures hover around 50 degrees Celsius, over 122 Fahrenheit, the air itself becomes a physical hazard. At these extremes, the human body loses its ability to cool itself. In 2024, hospitals faced over 40,000 reported cases of severe heat stroke. Here, you see volunteers rushing a collapsed patient out of an auto rickshaw and onto a hospital stretcher. The physical suffering in neighborhoods across Delhi and Kerala is the direct result of a massive atmospheric engine churning thousands of miles away in the equatorial Pacific. To understand why the subcontinent is burning, we have to look at the El Niño Southern Oscillation, or ENSO. Under normal conditions, strong trade winds blow east to west across the Pacific. But during an El Niño event, those winds weaken or reverse. This allows warm surface water to surge eastward toward the Americas. This oceanic heat reshapes global air currents, generating dry, high-pressure zones over India. These act as a physical wall, blocking the moisture-laden southwest monsoon that typically provides summer cooling. While El Niño is a natural cycle, it is now colliding with a baseline climate altered by industrial greenhouse gas emissions. A hotter atmosphere holds more thermal energy, meaning that when an El Niño event releases its pent-up heat, the resulting droughts and temperatures are far more intense than historical norms. This satellite data from the World Meteorological Organization recorded a 2 degrees Celsius spike above the normal baseline in the Central Pacific. This specific event ranks among the 5 highest sea surface temperature anomalies in recorded history. El Niño acts as the catalyst, turning global atmospheric warming into a localized weapon that strangles the Indian monsoon. Between April and June 2024, northwestern regions endured up to 10 severe heatwave days in a single month. In Rajasthan, the district of Churu recorded a peak temperature of 50.5 degrees Celsius, the highest the country has seen in 8 years. The most lethal threat occurs after the sun goes down. High-resolution mapping shows that very warm nights are increasing much faster than hot days. In dense urban areas, concrete and asphalt radiate heat back into the environment all night, depriving the human body of the opportunity to recover from the day's thermal stress. As the population relies on mechanical cooling to survive, the national power grid is stretched to its limits. In just 1 year, baseline electricity demand leaped by over 20 gigawatts, an amount equivalent to the entire power grid of a medium-sized European nation. This chart tracks the resulting vertical spike in demand. On April 25, 2026, India's electricity consumption hit a record 256.11 gigawatts, pushing the national infrastructure towards systemic collapse. The systems built to power modern life are actively buckling under a climate they were never designed to withstand. When temperatures pass 45 degrees, unair-conditioned classrooms operate like convection ovens. Here, you see children forced to study outside in a congested alleyway, relying on a single electric fan after heat closed their school. For millions of impoverished students, the school building is also the primary source of daily nutrition. When schools close due to heat, the government's midday meal pipeline is severed, turning a weather event into a malnutrition crisis for the nation's youth. This creates a condition called thermal injustice. While the wealthy can purchase immunity via air conditioning, the informal workforce faces a choice between fatal heat stroke and starvation. This extreme vulnerability became completely clear during the 2024 general elections, which were held during the absolute peak of the heat wave. On the final day of voting alone, 33 polling staff members died from heat stroke while managing ballot boxes in the sun. Extreme heat punishes poverty. It turns manual labor and basic civic participation into a gamble for those without protection. The emergency is global. In 2024, the Philippines recorded a heat index of 53 degrees Celsius. Across Europe, heat domes have killed tens of thousands. Here, crowds wade into the Trocadero fountain in Paris, seeking relief as their infrastructure is overwhelmed. However, European nations have begun responding with legally binding bans on outdoor labor during peak heat hours. In India, labor protections remain anemic, protecting mostly indoor factory workers and leaving the outdoor workforce legally exposed. India's heat action plans contain a critical flaw. They focus almost exclusively on daytime peaks. A cooling center that closes at 4 p.m. does nothing for a slum resident who cannot sleep at midnight because the ambient temperature is still 35 degrees. There is also the issue of statistical invisibility. Without a standardized system for recording heat-related deaths, many fatalities are logged as heart or organ failure. This allows governments to justify lower funding for mitigation. A global atmospheric shift cannot be managed with fragmented local policies that ignore the specific mechanics of how heat actually kills. While 2024 was record-breaking, the arrival of another El Niño in 2026 coincides with a disaster at the roof of the world. This is the Hindu Kush Himalaya region, the water tower of Asia, which feeds the continent's major river systems. This chart shows the collapse of the seasonal snowpack. In 2026, snow cover crashed to 27.8. The failure of these natural hydrological reserves ensures that future heat waves will strike a region stripped of its primary cooling defenses. A power grid hitting 256 gigawatts, 50-degree temperature peaks, and a shrinking Himalayan snowpack mark the end of the historical climate record. This level of extreme heat has become the standard for life on the subcontinent. Averting mass casualties requires a pivot from reactive measures to structural change, legally mandated labor protections, resilient power grids, and an urgent redesign of urban spaces for passive cooling. The heat has become an omnipresent apex predator, hunting the most vulnerable. As the planet continues to warm, the only question left is whether we are ready for what comes next.